Hiya, welcome to another build video. Something a bit different this time. It's a 46" long, I think 15" beam, yeah, birchwood fiberglass model boat. It's a cruiser's design. That's the lid for it. It comes in two parts, obviously, the lid and the hull. And that's about the size of it. It's quite enormous. I was really glad it wasn't any bigger, because everybody knows bigger is best. But if it had been any better, it would have been too good. I'd have never been able to take it anyway. But as it is, I'll show you what I've done to it so far. The lid, as you can see, it's very flimsy, probably 1.5mm thick at its thickest point. So I've reinforced it with some quarter ply. I'm going to reinforce this with quarter ply as well, and the lid is going to attach to the hull with probably about 10 Allen screws. Some waterproof tape round it, a small hatch in the back, probably that sort of size to let me get it, the electronics, any major jobs, and you take the lid off. For propulsion I'll be using one of these, not sure which yet. NTM prop drives, both of them. That's a 5060 at 380 kV, that's a 5050 at 580 kV. If I run that on 12 volt with the prop that I've chosen, which I'll show you in a minute, that should give me a top speed of around 16 miles an hour. Doesn't sound a lot, but this is an FPV endurance boat, it's not a racer. If I run it on 24 volts, it should give me 32 miles an hour, which is brisk by anybody's standards for a boat of this style. I'll show you the prop and the shaft. This is the propeller I'll be using. It's a 75mm diameter, 79mm pitch, and it's on a quarter flexi shaft. I've been told that it were a mistake getting a flexi shaft, but I'll explain my reasons. This is the motor deck. Excuse the tape. Reason for that should become obvious eventually. It's a sheet of 1/8 ply reinforced with another sheet of quarter cheap stuff. It's got a series of holes here. These 4 are for the motor mount, and these 14 the captive nuts under the tape, and the reason for them is I'll be running it on lead acid batteries. I'm not sure whether I'll be running it on 2 or 3, and I'm not sure of where they'll need to balance them. So these are all alternative tie down points for the lead acid battery, so I can have them wherever I need them. The motor deck will be fastened in with wells, if you like to call them that, at various points. These will be made out of glass fibre reinforced plastic, that putty that you get that you've seen me use before. It doesn't quite come to the front, as you see, and the reason for that is the entire under deck area, prop shaft, the whole lot, is going to be filled with expanding foam, which is going to come up here and hopefully flow out the top. That's mainly to give us a bit of impact resistance at the front, but it's also to reinforce the point at which you tow it. We go out in a boat quite a lot, and this would be probably towed behind us till we get to its destination, then off it goes and has a look around. I'll show you underneath. The shape under the hull wasn't exactly what I would have liked, but it's near enough. It's got a nice deep keel on, as you can see. This area, I'm a little bit worried about the prop getting knocked on rocks. We have lots of rocks around here. The solid part of the 1/4 inch flexi shaft only comes to about here, so I'm going to have to put a reinforcing bridge in this triangular area here, and I'll be fairing this off to something a bit more reasonable with some fiberglass putty. Other than that, there's not a great deal to say about the prop. The 1/4 inch flex drive actually had a 1/4 inch thread on the end, which was no good to me. The prop I wanted to use had a 5mm thread, so luckily I've got a lathe, so I machined the end of the shaft down and put a 5mm thread on it, and that's fine now. Got a lock nut at the back of the prop, so it's nice. This ferrule, I also machined that while I was at it. You want something that'll take the thrust of the prop. You don't want the thrust to be transferred to the motor bearings. So that's what that's all in aid of. I may yet solder, silver solder that is, a small keel on the bottom of the prop shaft once this is filled in and reinforced, just to protect the propeller. The rudder will mount at the back of the prop, obviously. And here we get to the reason why I wanted a flexi drive rather than a straight shaft. This isn't going to be a quick 10 minutes blast around and then you bring it ashore and fiddle with it and change batteries or refuel or whatever. Hopefully this is going to be out at sea, and I do mean the sea, not a pond, for several hours at a time. So I thought it prudent to get the motor end of the prop shaft above the waterline, and that's why I went for a flexi drive. I'll be treating the rudder the same. I'll bring that the top end of the rudder post well above the waterline. The waterline is roughly about the level of this deck, by the way, so we're only talking about 1.5 inches. But the last thing that I want to happen is for water to get into the hull while it's 5 miles away on an FPV mission. That would be pretty bad news. I'm not sure if I mentioned it, but these 3 holes are where I'll be injecting the foam. The deck will be tacked to the hull at the points where you see the black marks. In the meantime, put the foam in and hopefully it'll expand out of these. I'm deliberately leaving these gaps so that I can tell when it's full, and also that it doesn't build up so much pressure in there that either the hull or the deck gets warped or damaged in some other way. That's just a makeshift piece, of course. I'll show you the bottom deck ring. That's the bottom deck ring in place. The idea of this is to give it some triangulation for in case of side impacts. It's not totally unforeseeable that we could bang it into the boat that we're chasing it with or whatever. So there'll be a 1/4 inch thick piece of ply permanently bonded to the hull there, and then the other piece has an identical deck ring, as I said, 3 screws across the back, 2 there, 2 there, 2 there, 2 there, 1 at the front. Some tape around the outside to waterproof it, and that's basically how it'll sail. Hopefully very well. There's a lot of thought gone into it, but it's only the second model boat I've ever built, so it's all very much suck it and see. My wife's just been insisting off camera that I show you the cradle. You can't work on a boat this size without something to rest it on. So there's the cradle. It was the first thing we had to make, made specifically for this boat. But those of you who are familiar with my videos might know that my prime means of mobility is an electric scooter. So I will be attaching some side rails along here in the shape of an A-frame. It'll be made out of bent ply. I'll have a couple of bicycle wheels on the back so that I can tow this behind me to when we go to Windermere, or even just down the beach or whatever. The A-frame won't stay on the cradle. That's just for sitting on in the house, but it will be nice to have it for places where we can't just lift the boat out of the back of the car and straight into the water. So that's where we're up to now. A lot of preparation work's been done, and now for the next hour or so it's just a case of gluing, drilling and screwing. Oh, that life was so simple. Cheerio.